Hello, everyone. Welcome back to our third episode of the AI Agents, Bedrock AI Agents show. It is great to have you back with us. My name is Ivan Kopas, and I'm a senior technical trainer based out of Raleigh, North Carolina. And I specialize in our ML offerings. Let us know where you're joining us from today. We tend to get folks from all across the globe, so I'm curious. Let me know in the chat where are you folks joining us from. Here alongside with myself, I also have my good friends Dash and Forrest. So Dash, would you like to introduce yourself?
Of course. Hey, everyone. I am Dash. I am a former technical trainer here at AWS, now a senior solutions architect for public sector, joining all the way from Houston, Texas. So if you are in Texas, let us know. Maybe we can, talk about brisket recipes later. And I think we also have a Forest in the building.
Yo, hey, what's up, everybody? My name is Forrest Penland. I am also a former technical instructor, but now a senior technical account manager here at AWS. So these are my good buddies, Ivan and Dash. We're here again to talk about agents, Bedrock. Let's do it.
That's right. That's
Yeah.
right. Let's do it. And hey, before we get started today, we have a very, very special guest that we would like to introduce you to, Mike Messina, who's going to tell us a little bit more about some of the additional learning offerings as well as an upcoming learning opportunity there. So, welcome, Mike. Thank you for joining us. Would you like to introduce yourself and then tell us a little bit more about these amazing learning opportunities?
Yes, thanks so much for having me. Really appreciate being here. My name is Mike Messina. I'm the Generative AI Readiness Leader for the AWS Global Partner Enablement Org. I wanted to make you all aware of some great partner training resources for generative AI. If you're looking for self-paced digital training or game-based learning, or maybe you're preparing for one of our 4 AWS AI/ML focused certifications, head on over to aws.amazon.com/training. There you'll find hundreds of courses, including 5 partner-exclusive generative AI courses, 11 curated generative AI learning plans for partners. And speaking of exclusive training, I wanted to bring to your attention an upcoming partner virtual event that's happening on April 2nd. It's called the AWS Spotlight Day for Generative AI, with tracks for business and technical audiences delivered by AWS service and industry experts. You'll learn about generative AI-powered development and building your AWS competency with AWS. You'll explore real-world industry use cases and see live demos of transformative tools like Amazon Nova Foundation models, App Studio, and Amazon Q apps. You can find the registration link in chat. Hope to see you all there. Thanks so much for having me.
Thank you, Mike.
All right. Thank you, Mike, for joining us. Really, really appreciate it. And thank you for telling us about these amazing upcoming opportunities. Hopefully, we'll have as many folks sign up for those as possible. So thank you for joining us. Have great rest of your evening. And at this point in time, we're going to transition and talk about our upcoming content that we have for this episode 3. We have quite a bit of content here to cover, but before we get there, I would absolutely love to hear from you regarding how many episodes of our series have you watched. Again, this is our 3rd episode. We're not just getting started. We're pretty deep into agents. So let us know. Have you joined
here.
episodes? Have you joined 2? Or are you just confused what this even is? Are you just thinking, wait, you guys have done this before? Let us know in the chat. Type in 1, 2, or 3 to let us know here.
Eric is trolling.
Eric
has been here every episode.
Eric has been here every episode from the beginning to the end here. But you gotta admit, option number 3 is the most appealing one, the most interesting one. So I don't blame Eric for gravitating towards it.
Wait a minute. Come on, Eric. You're a super fan, You've been here for all of them.
Yes, that's right. But hey, trolling is always fun. So there you go. Anyone else? Let us know in the chat. I know sometimes there's a little bit of a delay with streaming to different platforms. We are streaming here to LinkedIn, to Twitch, to YouTube, and Facebook. So sometimes we get a little bit of a delay here in the stream, but let us know what your episode number this is. And also, as we're kind of getting started here, why don't we take a look at what journey we've been on so far as part of this series, as well as what are we going to talk about today and what's then left for the episode number 4. So with that, let's take a look. Let's take a look at our landing page here, and let's briefly walk through what this series is all about and what we're planning to cover here today. So this series is primarily focusing on diving deep into agents, not just any agents implemented anywhere, but specifically agents implemented in Bedrock. And how does Bedrock host our agents? How does it allow us to build them? What are some of the key features there? And of course, we love to see demos as well. So we'll have a few demos here in this episode as well coming up. So we've started this journey on March 3rd. This was two Mondays ago, where we talked about the agentic future, some very, very forward-looking discussion. If you missed it, there's the links here for the on-demand sessions that you can review and catch up on there. After the first episode, we talked about the components of intelligent agents, which is really important aspect to understand of when we work with agents, what can all they do, and which components you may decide to include, which ones you may want to exclude for a given use case. We've discussed that on the previous episode. Today, we're going to focus on implementing Amazon Bedrock agents. We're going to see a few implementations and a few helper tools that allow you to really quickly hit the ground running when you build your own agents there. And then the last episode number 4, is going to be airing next Monday. And we're going to there discuss the knowledge bases, implementation of knowledge bases in the context of agents. How do agents benefit from them? And how do you set them up in Bedrock there? So we're going to nicely finish with some conversations around RAG, retrieval augmented generation, next Monday. Now, this is quite of a packed agenda that we have here. I know everyone's really excited. So let's take a look at specifically what our agenda looks like. But before we get there, there was a home fun assignment. Dash, would you like to tell us a little bit more around what it was?
Yes. So the home fun assignment was to build out some architecture. So we've been talking about, using these agents and using, Bedrock and all these different features. But along with using those features, you still need to put it somewhere. You have to put it in a place.
That's right.
And we want to see what that place would look like. So we want to see your house. So not your actual house, your AWS house. So show us the place where you're going to put all these AI goodies.
All right, that's right. And we have Force here who has been working very, very hard as a TAM at AWS. And there's some architecting, quite a bit of architecting that happens when you are a TAM, Forrest. So maybe you can tell us from the perspective of the auto industry that you've been working really closely with, how may they build agents and what may architecture for automotive specifically include?
Yeah, thanks, Evan. I think it's really interesting. I mean, obviously, this is a really huge, interesting space, and all of the customers that I work with are working on this in different areas. Some of the really interesting things that are being used are like in the smart manufacturing space. Like around doing things like, hey, let's imagine we have like an assembly line, or we're a factory building auto components and things like that, and we have people coming and going, changing shifts and things like that. We've seen some use cases where we're building like sort of an assistant for that assembly line, right? Not only are we doing things like predictive maintenance activities, but also things like hey, like I don't know where, I'm trying to troubleshoot the installation of this broken part, right? Allowing the agent to connect to an internal knowledge base for maybe the previous shift where somebody already changed it, or even like a run book for, hey, here's exactly the instructions for replacing this component and things like that. So some really interesting real world use cases that are, accelerating the customers that we work with.
Excellent. Very, very cool, Forrest. Thank you for sharing that. And obviously, Forrest has done his home fun assignment. Very, very experienced in this area. But have you done your home fun assignment? That is what I'd like to hear from you next. So if you've done your home fun assignment, let us know. Type in one in the chat. If you just didn't quite get to it just yet, that's okay. Just be
Home
honest. Just
fun.
let us know.
I mean, who would not do home fun? Isn't that what life is about? Just having fun, right?
I think
That's
it
right.
is. Like I
That's
feel like
right.
more people should do a little home fun, or
That's
you
right.
just yeah.
It's also a really cool way to interact with us. We'd love to see people
Yep.
create your home fun assignment, post it on LinkedIn, tag us.
Mhm.
We'll comment on it. It's a great way to share your work out there as well. I think, in the world and the industry that we all live in, right?
Yeah.
Building that kind of your own portfolio of work. And so this is if you need ideas for that kind of thing, then tune in here and do your home fun, right?
Yeah, hashtag home fun.
Exactly. And as Forrest and Dash just mentioned, home fun is designed to be brief, concise, not taking up a lot of time, but still exposing you to building new skills. And hey, if you complete some of the home fun assignments, just tag us, post about it on LinkedIn, and we'll be more than happy to congratulate you for completing it, as well as potentially give you some tips on how may you expand the architecture that you have there. So with that, let's address what our agenda specifically looks like for today, because we actually have quite a bit of a packed agenda, awesomeness packed agenda of things to cover. We're
Awesomeness
going
pack.
to
I love it.
Exactly. So we're going to talk about these different types of configurations that you have to specify when you build your Bedrock agents. Perhaps if you built your Bedrock agents in the management console, maybe you've just glanced over these, or maybe you haven't even noticed that they're there. But it's really important to understand what they are and what configurations they include, because that allows you to create your agent to exactly fit the type of operation that you need out of it. So we'll talk about the types of configurations that happen during the build time of your agent, and we'll also cover some of the configurations you can set during the runtime as well. We'll touch upon the capability of Bedrock agents to keep the memory of what was discussed as part of their session with different users, and we'll see how they actually summarize the previous discussions to enable very efficient storage and reference to what was discussed in the past. Now, when you interact with Bedrock agents, there's going to be these traces that get emitted that let you into the mindset, into the brain of the agent. They help you understand through these tracing, they help you understand what the agent is thinking, what is it planning to do, and why it's deciding to potentially utilize a set of tools that are available at its disposal. Aside from that, we're going to do a little bit of a demoing. We're going to do quite a bit of demos in this session. I'll walk you through the Bedrock agent generator to help you understand what you can use to potentially get started very rapidly on building your agents. And in fact, we're going to do that here together. We're going to build an agent from scratch, and we're going to see how we can use that helper tool to go from nothing to a fully running agent in less than 2 minutes in total. And then we're also going to expand the usage of agents into more holistic, more expensive type of an architecture for a real life use case, such as the marketing use case, where we have to create the personalized marketing content based on various knowledge bases, data we have there, based on some of the recommendations that Amazon Personalized has produced, based on some of the information we have stored in our database. And that is going to be my version of the home fun assignment that I've completed based on the previous episode that we have, where I'll walk you through the architecture of the solution, and then we'll dive into how the solution works as well. Of course, as with previous episodes, we're going to be wrapping up with the next home fun assignment, which is going to give you some new ideas around how to get even deeper into this content. So how does that sound for us?
It sounds like a good time to me. Can we play I think we should play the agents drinking game every time
Yeah,
Ivan says agents, we're gonna
it
take a
is
drink,
after hours.
yeah.
Water.
Yeah, we'll
Water.
go with water for now
Sure,
though.
sure. This
But
is water too.
yeah.
Wink, wink.
Yeah.
Yeah,
But yeah,
and we
no, I
got
think this is sorry, I
yeah, we
say
got
this is
thumbs
cool,
up
cool.
from Dash as well. So I think we're ready to get started. But yeah, did you want to say
Yeah.
something for us?
Oh yeah, no, I agree with the awesomeness that's packed in this agenda. And the first couple episodes, right? We kind of talked about what are agents and some of the initial components. This is where we really start diving into the nuts and bolts of what's happening sort of behind the scenes. So hang on to your agents and let's go for an awesomeness packed ride.
Sounds good. So we have quite a bit to cover. So why don't we get started to make sure we cover everything we prepare for you folks for today. So Dash, why don't you tell us a little bit more about the item number 1, the build time configurations? What does that all include, and why would you want to configure those things?
I can do that, absolutely. So since we're getting down to the nuts and bolts, why don't we talk about build time and runtime? So I'm going to start with how Bedrock agents work, and we're going to focus on this build time operations. So when we're thinking about build time, there's 4 components you really want to think about. First, foundation model, instructions, action groups, and prompt templates. So what are these things? And are you going to show me something that's not on the screen? Maybe. There could be one more thing that's also on this list, but we've already talked about, so I didn't mention it, but you tell me. But first, when we think about foundation models, this is the agent that you're going to use that's actually going to do the inputs, is how the prompts are going to respond. It's going to determine what type of orchestration process you use, all of those things. So this is kind of the ingredients to the cake that you're baking. These are the main ingredients that you want to put in. Then instructions. Instructions are how you describe what you want done. So when you get your agents and you figure out what it is you want your agents to do, instructions are what tell those agents what to do. So it's like, the recipe. So you have the ingredients, now you're going to give it the recipe. We then have action groups. Action groups are the actions that the agent should perform. So how you're actually following the steps: mix dough, set oven, place in oven, set timer. These are your action groups, the things that you're actually doing to make the cake. When we think about action groups, there are different things within them. One of the things being an open API. So open APIs are actually going to define the API operations that your agents are going to invoke. So if I want to open the oven, then I need to have an open oven API call. When I actually do that action, that is that open API within my action group. I told you there may be something that we've already talked about that pops up, and it's knowledge bases. We've talked about knowledge bases. We know what knowledge bases are. Forrest even brought it up in his example where you're looking to perform a task, and there's a lake of knowledge that exists in some place. And you're going to pull from that lake of knowledge to be able to perform your actions, answer your questions, all of those good things. So we know what knowledge bases are. We've had to write KB articles before. We, as IT people, we love them. We don't love them as much when we're the ones writing them. Maybe we don't use them. You should use them, by the way. 5 minutes of reading instructions can save you from 3 hours of troubleshooting. I'm not taking my own advice. I just want you all to know that. I said that and I don't do it. The other thing is prompt responses. So prompt templates. Prompt templates are what you use to create your prompts that you're going to provide to the foundational model. So the prompt, we all know, is what you write to make the thing do the thing you want it to do, or to ask the question, or to perform the action. So I'm going to write out a prompt, and the way that I specify my prompt is what's going to determine how the agent works and what output it gives me. So you can actually have templates and use those templates to figure out how to best make the agent do the work for you, or how to get the best output out of the agent itself. So when we think about build time, think about baking a cake. I need my ingredients. I need the recipe. There are actions that I'm going to have to perform when I'm writing these, when I'm baking this cake or doing this recipe. One thing that I forgot to mention about open APIs, we use open APIs when we want to give it explicit rules. So if we want to tell it to follow something specifically, a specific set of actions that I want you to take, that's when we use open API. Again, we can also use things like Lambda functions. Lambda functions will also work in action groups for us because we're, again, just telling it what to do. We know about knowledge bases, and then we're going to think about prompt templates as well. So if I scroll down a little bit, you're going to start seeing words like prepare. You're going to see, like pre-processing and orchestration and knowledge bases. And those things are important in post-processing as well. But I'm not one to steal someone's thunder. So I am going to tell you that these are a part of prompt templates, but someone else is going to explain pre-processing, organization, and post-processing for us. But the part that Daz is going to talk about, this is where we are right now. We have the action group, whether it be Open API or Lambda. Remember, Open API, explicit instructions, Lambda for the things that may not be as explicit. We can also have knowledge bases. These are the things we're going to use in conjunction with our agent, our foundation model, whatever it is. We'll also have some based prompt templates, the things that let us know how we can get the most out of our agent and our foundation model. And it'll be tied to a prompt store. So as we start to write those prompts to interact with that foundation model to get that output, we stop here because the next part is what we're going to talk about with the runtime. Right now, we're just building. With that being said, I do believe I have a question or two for you. And I'm going to ask you all, you built an agent that can perform tasks such as searching for hotel discounts. It is doing a thing and booking a hotel for you. Which component performs these tasks? In our steps of baking our cake, is this the ingredients? Actually baking the cake? What are we doing?
Right. So let us know, folks. So what do you think? Type in 1 through 4 in the chat. Which one of these has ability to get things done for the agent? And thank you, Dash, for walking us through some of the build time configurations that we have in place. As you folks are thinking, we also have a few questions here around the programmatic approach to deploying agents as well. So how can you configure these items during the build time using programmatic approach? So I've shared some examples that use both the command line interface as well as the CDK as well. And if you folks ever have any questions around various examples of how to do something, how to do XYZ, feel free to connect with us on LinkedIn and let us know. We'd be more than happy to point you in the right direction. So it looks like we have a variety where we have various folks who have responded to the poll here. And it looks like everyone is saying the answer here is the action group. So what do we think, Dash? Is that correct?
I think that's a good guess. I think action group is the correct answer. we're looking for it to perform tasks. So because we're looking for it to perform tasks, that is going to be our action group.
Go
and
figure. It's the thing that performs the action. Yeah,
I know,
right.
I know. and because you all got this one right, and I think we're going to double up. We're going to ask another question that is around action groups. You want your agent to clearly understand parameters each of the actions need as inputs. You're giving it something explicit. You want it to understand something that is explicit and specific. Which element allows you to specify? What are we thinking? I see some 3s. I see some 2s.
That's right.
We're thinking possibly prompt templates. We're thinking possibly open API schemas.
Mm-hmm.
We
All right,
want
maybe let's let a few more folks here respond. So it looks like we're split between the prompt template and the open API schema. It looks like we're a little more heavily leaning towards the open API schema. So how would you approach thinking about this, Dash?
So the way that I would approach thinking about this is we are within our action group. And remember, our action groups, you can either have Lambda functions or schemas, open API schemas. And depending on if we want the actions to be explicit and specific, we would use that open API schema. So you just learned the first half of doing this.
Mm-hmm.
We just learned that build time. Now that we've learned that build time, I think Forrest should give us a little intro into runtime.
So yeah,
Sounds
like
great.
okay, so first of all, right, like we have to build our agent, right? Like and the reason it's broken down like this, right, is there's kind of like there's basically 2 different sets of APIs, right, when you're interacting with AWS and interacting with Bedrock, right? So thanks Dash for going over kind of that first set of the build time APIs, right? So this is like a collection of APIs that you're going to interact with when setting up and building your agent, right? And then once that agent has been invoked, we're going to call like an invoke agent API action. Now we've moved into that sort of runtime agent, right? And so this page, I think here does a pretty good job of breaking it down. Maybe someone else can throw the link into chat, right? But again, it talks through the build time configuration that Dash was so kind to guide us through, right? But now that we've got our agent put together, all of those recipes to create the cake are sort of built. Now it's time to take it out of the oven and actually eat the cake, right? So that's where we get into the runtime process. This is what happens when you call that invoke agent API. And it's actually pretty interesting. I'll show you a little demo of this in the console here in a minute, because I think it really helps sort of break down this workflow, right? So imagine you're using a chat bot or some way of interacting with the foundation models, right? We're gonna feed in a user prompt, but then our agent is actually going to go through these different phases. It's going to start by doing some pre-processing. And this is how the agent, we actually can provide the agent some instructions, say, okay, based on the user's input, now I want to like validate my understanding of it, right? So how does the agent contextualize and categorize so that we know what to do from an orchestration perspective? So we know which what part of that action group we need to how that action group is actually going to invoke additional APIs, invoke our Lambda functions, go out and actually do the thing, right? So we start with pre-processing, understand what make sure our input is valid, make sure our input is safe and not outside of the guidelines of our application, things like that, right? And then once we've sort of categorized that prompt, then we can go into that orchestration phrase, right? Where we decide, hey, do we need to do something with an action group? Do we need to query a knowledge base? and so on, right? So agent interprets, like sends some information into the foundation model and gets some guidance back on what it should do, right? So what it's going to predict whether or not we need to trigger an action group or go look up for some more information from a knowledge base, for example. Right?
And this is something, Forrest, that since the agent is trying to, as you said, predict what's the action should be taken, that kind of tells us that not every prediction is accurate. So if we're consistently seeing that the agent is not taking the right steps, this is potentially a good opportunity to either try using a different LLM for reasoning purposes, or even more importantly, revisit that open API schema that Dash talked about, that outlines what different APIs can be called, what are the descriptions, what are the inputs, because maybe some of those APIs that the agent can call have potentially misleading description of what the API does, which leads the agent to think that maybe that should be the right step to take. And later on, Forrest will show you how you can troubleshoot your agents and get to see what those steps are. But this is interesting to see, like the framing and the documentation that the agent is going to predict, right? It may not actually be the right next step to take.
I like to think of it as kind of like it's sort of that chain of thought where we're like, hey, this is what I think I want to do. Let's make sure that I really fully understand, right? It's like we're active listening. Like I ask Ivan a question, he's like repeats the question back to me to make sure that he fully understands the question that I've asked him, right? And that's sort of what's happening in this, or it really is what's happening in this pre-processing phase, so that it knows how to go about doing the next steps of orchestration. And then we can even fall after that. There's even a post-processing phase that will sort of double check the results before returning it to the user, right? And we can actually see this if we go into here. Actually, sorry, I'm skipping ahead and showing you some of the monitoring components that we have here. But if we go back here into our agents, I have this little agent that we created down here under the, sorry, if I could go into the agent builder, and you can actually see how these, we have this orchestration strategy, and this is where we define how we want to handle pre-processing, orchestration, post-processing, and all of the Bedrock agents have sort of this pre-built default pre-processing template. And if you take a look at this, it's actually pretty detailed. I don't read out the whole thing, but essentially it gives the agent some instructions. It says, do this first, right? And in this case, this is just the default prompt template for oops, and apparently I deleted it. So we'll just cancel.
I can just
that.
X out of it. Yeah, but the when it comes to these predefined defaults, this kind of reminds me of working with the CDK Cloud Development Kit, where you want to deploy different resources to AWS, and there's various predefined best practice configurations that are in place, so you don't have to configure everything yourself. So in a similar fashion, when Bedrock allows us to deploy Bedrock agents, you actually don't have to create these things from scratch. The default prompts that they have for each of these stages that Forrest just talked about are actually pretty good, pretty solid, pretty concise and detailed, and they tend to work well in many scenarios. However, as Forrest just showed us, in this editor, you have ability to change these prompts, and this allows you to further tweak how the agent navigates through these different stages. But if you decide to just quickly build a proof of concept that is, you don't have a lot of time, you just want to see how something may work, you can actually get that done really, really quickly by using some of these predefined defaults.
Yeah, and they're pretty good out of the box too, right? I mean, the idea behind, and I thought looking at this was really what helped me sort of solidify my understanding of how this works, right? This pre-processing step, this particular prompt, right? It says basically you're a classifying agent, and you're going to take that user's input and put it into different categories, which is going to tell you exactly what you need to do next, right? So like the categories that this thing puts it into is hey, from a safety perspective, we're looking at is it malicious and harmful? Is it, are we trying to call an API or getting some sort of external function, right? Maybe it's something that we can't do, or maybe it's something that we do need to send to our action group to trigger some sort of external API, for example, right? And then categories, inputs that are not questions, but are answers to questions. And so this is like that question and response workflow, right? By feeding the agent back some more information, right? And then, that ultimately determines how it handles orchestration. Again, there's a predefined prompt here that tells it what to do. You've been provided a set of functions to answer the user's question. And this is where it can pass in like that action group, which is like your tool that it's going to use for different things. And then there's, how do we want to interact with our knowledge base? And then what do we want to do at the end, right? So, and this last one, it's right, it kind of just summarizes what the agent's job is and how it's supposed to return that result to the end users, right? So I think it's just understanding how these flow together is super powerful when it comes to designing, our agentic workflows, right?
Right. And to Force's point out, I'm just catching up with some of the questions here in the chat. James had a pretty good question on how in some scenarios, we kind of touched upon this, the agent may actually not do a very good job at the task that's being presented to it. So it looks like in this case, James is looking to potentially have the agent work with the timestamps and calculate potentially, if I'm following along, what is the right month within a given date here. Now, anything that relates that it's related to math operations, you oftentimes want to externalize, do it outside of the LLM itself. Instead of doing that within the LLM and having the LLM do the math, extract dates, and so on, it's oftentimes, especially when you consistently see that it's unable to solve a particular problem, it's oftentimes better to externalize that into a particular tool where you can implement very, very easily Python code that runs on a Lambda function that can perform this extraction and tell you what month it is there. So a lot of the work on the agents that we do, we try and figure out how far can the LLM itself take us. But keep in mind, the LLM is not meant to solve every problem that's presented to it. It's meant to understand how to offload the tasks to the tools that it has. So as long as we have the Python script, which we can easily implement on a Lambda function that can easily perform this extraction of the dates, and as long as the description of what the Lambda function does is very clearly configured as an action in the action groups, all that LLM really needs to understand how to do well is choose that tool to perform that task when the time comes to do it. So if you now that's discussion here is around this particular use case, but same applies for other use cases as well. When you have a scenario where the agent is unable to complete some task, try and externalize that into a tool that the agent can call instead of the LLM needing to perform that task. But with that, we're now diving a little bit deeper into the some of these additional runtime configurations. So would you like to walk us through this diagram for us here?
Yeah, I thought that this was another good, outside of like kind of looking at how it goes together inside the Bedrock console, this is a good visual representation of this flow, right? So again, right, user asks a question, right? Like, I don't know, maybe like who asked the question about the date? We're like,
James.
Today's date, maybe that's the user input, right? And so we didn't talk too much about this, but there's also the capability of having a predefined prompt store, right? So we can have like a customized prompts that we can say, and like maybe one of those customized prompt in this example is like, what's today's date? Like that customized prompt might say something like, based on the user's input, go run this, Lambda function instead, something like that, as opposed to just more of an open-ended question. Or the user is trying to find out the exact date and time in this specific, I want the results in this specific format, et cetera, right? That kind of predefined sets of prompts, so you don't have to recreate them every time. this goes back to that idea of like agents having a memory, right? There's this also a session store where basically we can pull in past sessions for so that we can keep context, right? And then we ultimately send that into this pre-processing phase where we actually go out and invoke a model. That model invoke on the pre-processing is going to say, hey, yeah, is all of that stuff, user input, existing prompts, conversation history, is it valid, right? Does it meet the rules that we've sort of laid out? Is it compliant, right? And then we kind of move on to that. Then we move into this like orchestration phase, where again we're going to call the model, maybe based on the results from that from the model. That's where we decide, hey, okay, now we need to go out and invoke our action group, right? Run a Lambda function to go maybe do a web search, maybe call another external API to retrieve data. Maybe it's call a Lambda function that simply calculates and returns a specific exact date timestamp, right? Something like that. Or maybe it's go out to a knowledge base. All of these things kind of put together give us what we call an observation, right? Like what, based on that pre-processing, what does the model predict that we want to return? Okay, now we're going to go back that we've kind of gone through that pre-processing phase. We've gathered all the other parts of the cake, if you will. And we're going to say, okay, here's our observation. We've got this. This is the user's question. This is where we need to go to an external data source to get information. And we'll feed that back in to the prompt and sort of rinse and repeat until we get the result that we want, right?
Yeah, that makes sense. And thank you for walking us through this flow, Forest. Now, before we pull up maybe a couple of questions here, I'd like to pull up a question from James here. If you want to query AWS resources, for instance, the count of 400 level HTTP error codes on API gateway, do you still have to create an action group and use Boto3 to query it? Yeah, actually, that will be the ideal way to do it, because you need to have some sort of a tool that the agent can call to retrieve this information. And it's very easy to implement that exactly as you laid it out, James, having a Boto3 if we choose to use Python, because it doesn't have to be Python. That is the beauty of using Lambda functions, right? Lambda functions have the various built-in runtimes for Java, for Go, for Ruby, for Node.js. So you don't actually have to use Python, because to the agent itself, it doesn't actually matter what the implementation of the tool is behind the scenes. All that the agent needs to know is what are the available APIs and what are the expected inputs and outputs to those APIs. And it's just going to send an API request, which is going to be processed by a Lambda function where you implement this type of a logic using the language of your choice. Heck, you can even have the custom Lambda runtime where you build really anything that can run on Lambda and implement your tool in any way, any language that you see fit. But with that, why don't we bring up some questions regarding what Forrest just told us about?
Hey, Ivan, while you're bringing that up, that particular question is pretty interesting, though. So, like, the idea there, the use case is somebody building an agent to troubleshoot AWS API gateway errors, right?
That's right.
Go check out. There's a feature of Amazon Q called Q Developer Operational Investigations, built into CloudWatch now, that will actually allow you to do some of that, right? You can talk to Q and have it help you investigate API gateway errors and things like that. It's a newer feature. It's sort of just in preview right now, but go check out. It's called Q Developer Operational Investigations. I think I just dropped a link to it in the chat. So for that particular use case, maybe you don't have to build your own agent. We've already got one. So
No, that's right. And Q is a very, very good example. Q developer specifically is a very, very good example of the real world agent implementation that's designed specifically to enhance the utilization and efficiency of developers. But now, as Forrest mentioned, it's kind of getting deeper into the SysOps side of things and helping us troubleshoot issues as well. So with that, we have a question here. So what is this question about, Forrest?
So this one says you want to validate that the input to your Bedrock agent is safe. Which one of these components can you use to easily set that up, right? Where might we check that, the input that our user has wrote is following the rules, right? Like, is it safe? Is it well formatted? Do we understand what we're trying to accomplish here? Might that be in the orchestration phase, pre-processing, post-processing? Do we do that behind the scenes magically with a Lambda function? What does everybody think, right?
I'm seeing twos in the chat.
That's right.
Sounds pretty good to me. Do some pre-processing to check what category we fall into. Are we trying to do something malicious or something that our agent wasn't really designed to do, right?
That's right. So how does this, and that, by the way, great job. That is a correct answer here. So how does this different, Forrest, when we talk about safety and agents with trying to do some of the safety tasks as part of the pre-processing, how's that different from Bedrock guardrails, which we know have been also specifically designed for improving the safety of LLMs, but then, of course, that extends to the agents as well. How's this different?
Yeah, so I think these things are similar and kind of complement each other, right? The guardrails are really are sort of that additional step to check that, like, the output from the agent is not returning things like PII information and things like that. Whereas the pre-processing rule is really happening like at the user input side to make sure we know like what sort of question that we're asking, right? Categorize that question and decide which part of our action group we need to trigger. Does it need to go here? Does it need to go there? Are we going to kick it out because it's asking for something that's malicious or not supported by the instructions that we give the agent, right? So these two things work together definitely. Whereas the guardrails are, hey, this is the maximum thing that our agent can do when we invoke an LLM. Whereas pre-processing is sort of like those general rules that we feed in along with the prompt, right?
All right, makes sense. Thank you for that clarification, Forrest. And now we have one more question before we move on and talk about the next topic. So what is this question about, Forrest?
Yeah, so this is kind of just that workflow we walk through, right, in the documentation where we look at all of the steps that happen, pre-processing, orchestration, knowledge bases. What ultimately is the agent doing, right? Like, what is the result of that, right? After we go through that, we return back to the user. Do we give them a rationale, a trace, an open API schema, or an observation? What do you think?
All right, what do we think, folks? Any guesses here on this one?
What are we thinking?
Looks like we have.
Does
some
anybody
more.
have some observations that they would like to make?
Was that a hand? I don't know.
I feel like you may have given that one away.
Oh, we don't make it too easy around here, right?
All right, great job, folks.
There we
It
go.
is an observation. And now, before we move forward and we talk about the agentic memory, Let's bring up one question here from James on, hey, can the agent be considered both the customer and or an employee? What do you think, Dash?
So I think it's going to depend on how you're using it. So it's going to depend on what output you're trying to get and what input you're giving. So yes, but it is situational.
Yeah, I agree. And you can have a first off, you can have multi-agent architectures where multiple agents talk to each other, and as part of that, one could be a customer, another one could be an employee. Another example will be a potential future that we have ahead of us, where if I want to get a lower rate on, let's say, insurance, I may have my agent that goes out and negotiates with the agents of different insurance companies and tries to get the lowest rate amongst all of them. That's kind of what you do nowadays. You do it yourself, and you speak to another human on the insurance side. But hey, in the future, I may have my agent whose task is to get me the lowest insurance quote possible, and my agent may need to negotiate with agents of the insurance company. So to your question, absolutely, James, in the future, for sure, the agents can be both customers, employees, and the as well as the managers to an extent as well. So with that, why don't we shift gears and talk about the next topic, Dash. So tell us a little bit more about the memory in agents.
Oh yeah. So if you remember, hint hint, wink wink, we talked about this last week. So it is on the last episode. So I'm not going to spend a lot of time on it, but there are some things that I do want to focus in on. So first of all, memory retention across multiple sessions. So this is again your agent actually remembering past responses that it can use to keep it make it more conversational rather than having to you having to re-explain what it is you're looking for each and every time. You kind of have a chain of prompts, and those chain of prompts can remember or recall past actions to build on what it is that you're asking. So first things first, this is fully managed and serverless. When you go into it and you turn on the memory, hint, hint, wink, wink, you do have to turn on the memory. It is something you have to enable. But once you do, you don't have to manage the memory itself. It's not a server or a cache that you're actually interacting with. This is going to allow it to retain conversational context across multiple sessions. So it's not just memory within the session, it's memory from previous sessions as well. What's going to happen is once you actually go ahead and use the prompts, put it in, as it's storing that memory, it's actually going to be something that's done asynchronously. So all the summarization that's done is done after the session ends. That way it doesn't have any impact on the session itself. Doing it this way, rather than like having like your own memory that you attach to it, is more cost effective. It's going to store things in a more efficient way instead of trying to do word to word memory where it remembers every single thing. It's going to remember the most recent thing. Remember those rules of five, that magic 7. So 5 to 9 things it will store. So it has a smaller footprint. And yeah, it's just one of those things where it allows you to bring in things from before into the session you have now. So you're not recreating the wheel each and every time. So one last thing that I do want you to remember about this is the memory duration itself. You can get up to 365 days, as Enrique said in the chat there. And with that being said, I know I went through that really, really quickly, but there is a question that I have for you. And the question that I'm going to ask you is around using the prompt itself. Now, did you, or using memory, did you hear me say anything at all about having to provide a prompt template that explains how the session summary should be done? Did you hear me say that at all? If you did, the answer is true, or 1. If you did not, The answer is false, which is 2. So do we think when we enable memory for Bedrock agents, we have to provide a prompt template that explains how the session summary will be done? I'm seeing a lot of 2s. I'm seeing a lot of people say, Dash, you never said such a thing. I never heard those words come from your lips. And you would be correct. It is false. You do not.
Hard job. Well done, Dash, on this one. And that's one of the beauties of using Bedrock for these variety of different tasks and components. Agents are just one component within Bedrock. Holistically, if you take a look at various other components that Bedrock has, one thing that they all have in common is that they're all fully managed. They're all serverless. So just like Dash mentioned, many of the things you can create without specifying all the components, to the point where almost first time you do it, you're almost not even aware of what all configurations are in place, because Bedrock doesn't require you to specify those. It does allow you to customize and tweak those, but it's not required that you specify it up front. So when it comes to creating a proof of concept very, very quickly, it's very easy to do that with Bedrock. And one of the reasons we're telling you about all these different configurations and features is so that you can be aware of various things that may not be as evident upfront the first time you go through creating these things around. So something that's really interesting about Bedrock as well, especially as you interact with the agents, is the ability to get into the mind of an agent and try and understand how does the agent take the actions, how does it decide which action should be next, how does it observe the outputs of those actions. So Forrest, why don't you tell us a little bit more about the tracing aspect of agents?
Yeah, absolutely. I think that's a really good point, Ivan. Like, just sort of, Bedrock does all of these things for us like very easily, but it is super important to understand how all of these things go together, because that's where the true power of customization and being able to truly create some unique excuse me experiences, and being able to truly take our AI workloads to the next level, right? And so on that point, tracing is a really great way to sort of understand how all of these phases are working and what is actually being returned back to to the LLM, right? So first of all, we'll start here. Let me bring this up. Going to start here with the good old handy dandy AWS documentation. If you want to track your agent's step-by-step reasoning process, you can do it using traces, right? So basically, each time our agent goes out and sends something to the LLM for a response, it's going to record exactly what happened, what the input was, what the response is. And this is how you're going to see kind of the results of those pre-processing orchestration phases as well, right? So each response from a Bedrock agent is accompanied by a trace that details the steps being orchestrated by the agent, right? We can go through here, and this kind of breaks down what a trace looks like. This gives us all the different fields that might be in a trace part, right? The agent ID, the agent name, collaborator name, if we've got multi-agent workflows, for example, agent aliases, session IDs, caller chain, basically everything that we would need to debug if we're having problems with our agent. Or also, I think this helps, at least for me, when I've started building some agents. The tracing has really helped me sort of rethink about how I'm using my prompts and how I need to tune them to kind of get the result that I ultimately want to get, right? And we have tracing at every phase of that runtime, right? So we have a pre-processing trace, orchestration, post-processing, and then some other custom ones we can do, and routing classifiers and things like that, failures, guardrails. So again, everything that our agent is doing, we are going to be capturing those traces. And again, the documentation, it's fun to read through, but I think it's also really handy to sort of look at this in practice. So here I have this little test agent set up, and this is one that I've got tied in. We talked about like the SERP API and Tavali APIs that we could use to do web searches with our agents. And so that's what this agent is connected to, right? And so I gave it this simple question: what is the weather today in New York City? And here's the response, right? So according to the latest weather, right, 65, partly cloudy. That sounds about right, right? And it even gives us how it was able to do this, right? So I was able to gather this information by performing a Google search for the current weather in NYC. Okay, so that's what the user got back. But how did it go about getting this, right? So let's start with pre-processing. And here we have trace at step 1. I mean, this might hurt your eyes to look through this whole entire thing. Let's see. Can I zoom this in a little bit?
I think it's visible enough.
Good enough.
Yeah,
You see it?
that's
Okay.
better.
A little bit better. All right. So like here again, here's the agent alias, and we're gonna. This gives us again sort of that pre-processing prompt that we looked at earlier, right? So you're a classifying agent that filters user inputs into categories, and you can sort of read through the whole thing, right? And so at some point in here, though, it is going to say, here's our action group, and we have this web search and Tavali AI search tool that I can use, right? And you can go through and see how this like went through its whole reasoning. If you scroll down here to the bottom, it kind of gives you the result. Like you don't have to read the entire prompt. Like this is all of those prompts sort of combined together at the pre-processing phase, and ultimately here is sort of its observation, if you will. The user's input is a simple question about the weather in New York City. Straightforward query. How do I do this? I need to use my Google search tool, right? It doesn't contain malicious or harmful content, so we can kind of proceed on to the next phase, right? Here's the raw results, and then from there it gets passed into like our orchestration and knowledge base prompt, right? Again, we can step through each phase of it along the way and see exactly what it did, right? And so our agent has some instructions. You're an agent that can handle various tasks, helping users do research. We have different options for search, Google search, Tavali search, again, based on sort of what the result is from that pre-processing phase. It directs it on how to choose these different search mechanisms, right? In our action group. Again, this is all of the things kind of combined together to determine what it's going to do. But then down here at the end, it's right to find the current weather in NYC. I'll perform this Google search, right?
Excellent. That's really cool walkthrough, Forrest. So thank you for walking us through this. And why don't we, at this point in time, just for the sake of time, move forward? And I want to make sure we address one question from James here. A very good question on giving the agents the autonomy. So this is where in this particular scenario where James is bringing up, it's really important for us to sometimes try and differentiate on whether agents are even required to solve particular problems. So if the goal of this to when particular thresholds on metrics are exceeded for me to get notified, I actually do not need an agent for that. All I need is to set up some CloudWatch alarms. They're going to get set when we have metrics exceed those thresholds. And then through simple notification service, I can get notified through Slack, through email, through text message, through push notification. But on the other hand, if the goal of this particular agent will be for me to, in natural language, chat with it, and for it to come back and tell me what are the values of different metrics for different. I can ask it, what's the capacity of the DynamoDB table that's being utilized, and I can go and ask it, hey, what's the queue depth of this queue? If that is the use case we have at hand, then agents are absolutely a good way to implement that, because I can interact in natural language with the agent, and that allows the agent behind the scenes to call the Lambda function, which can be pretty broadly implemented to scan across the CloudWatch metrics and let me know what the values of different metrics are. As long as I, as a user, as an entity that's interacting with the agent, can specify what is the metric name that I'm interested in, then that Lambda function behind the scenes can be pretty broad because it's going to get the metric name from the user, from myself. And if the user does not specify it up front, agent will follow up and ask, hey, what is the metric that you're looking to get? So that is one way to kind of think about whether you need an agent or not, because we don't always need to have an agent. It's important to select it only for the use cases that require it. But with that, we would love to use the remaining 15 to 20 minutes to show you a couple of demos of how you can build your agents from scratch and how you may engage into building a greater architecture that involves agents. So to do that, we're going to take a look at this PartyRock app that I've created to assist you with getting started with agents. So this tool is going to help us create the Bedrock agent artifacts by generating an open API schema that we heard from Dash about, the Lambda function code, which are some of the things that we heard Forrest talk about earlier, as well as the setup instructions based on our description. So all that we have to do is we have to populate this first field here with a clear description of what we want that Bedrock agent to do, and then PartyRock the app is going to generate all the artifacts for us. So let's take a look at how this may work, and let's build an agent from scratch ourselves. So what I'm going to do here is I'm going to say perform all algebraic operations. And this is going to be the particular tool that can perform various calculations using Lambda function behind the scenes. Again, for any types of calculations, oftentimes it's more efficient and less error prone to have a tool perform that task for us. So we're going to provide that as the very, very brief instruction, and we're going to run this. Again, we're just going to confirm that we are humans after all. And let's see if I can pass that test, because a lot of things looks like bags here. Okay, so at this point in time, it's generating the few things that we need. Is generating the instructions for the agent that we're going to need to provide to the large language model. It's going to generate the open API schema, which is going to have a variety of the APIs that can be called, like the calculate API, which performs the specific algebraic operation on two numbers. And if you scroll further down, we'll see some of the error handling included here as well. And then also there's going to be a Lambda function that gets generated that can potentially implement this. So it's going to include some of the helper functions, like the calculate helper function, and it's going to say if the particular operation is addition, subtraction, multiplication. It's going to implement those steps here for us. And if we scroll further down, we're going to see the Lambda handler, which you can think about as a main function for Lambda. When your Lambda gets invoked, that Lambda handler gets called there. So we're going to have this API path /calculate that is implemented here, which is going to call that a helper function calculate and pass the input from the agent. So with that, if you scroll further down, there's some instructions on how can you go about creating an agent out of these artifacts here moving forward, the setup instructions as well as a clarification chat in case if you have some questions about some of the artifacts, you're not quite sure how Open API schema works. So if something breaks as you're creating the agent, you can also use this clarification chat to troubleshoot the problems that you're observing. So let's give this a shot. Let's get started and let's try to create an agent based on what we have here. And let's see if we can be successful at that. So the first step here is the instructions for the agent. So let me copy that and let's go into my AWS account, and I'm going to navigate to Bedrock service and then to agents. So we can go ahead and create an agent from scratch. Now, if you scroll further down here, on the left-hand side under the builder tools and select agents, we are going to be able to create a new agent just by using the agent builder here. And I'm going to call this agent math agent as an example. So with that, I'm going to create this agent, and this is where we start incorporating those artifacts that the PartyRock app has generated for us. I'm going to just maximize our screen here, move forward where we get to select the LLM that is going to be performing the rationalizing of what actions need to be taken and how to orchestrate them. This is where pre-default setting is going to be to use Claude 3.5 Sonnet version 1. In reality, as we discussed in the previous episodes, you want to be very careful with what LLMs you select. Specifically, you want to be selecting the smallest LLM that can perform the tasks. Now, let me know in the chat, what do you folks think that I'm saying to choose the smallest LLM? Why not take the largest? Why is that potentially not a good idea to do? So let me know in the chat, why is smaller better when it comes to these agents here? So I'm going to, instead of Claude 3.5 Sonnet, I'm going to, as you folks think, I'm going to choose a smaller model. I'm going to choose the Claude 3.5 Haiku, which is a much, much smaller model than Sonnet here. And then we have a few folks here chiming in. Eric is saying it's going to potentially save us dollars if we use smaller models. And if you kind of think about how frequently these agents utilize LLMs, you can actually reduce costs substantially by using the smaller LLM. And also, second point from Eric here, it's also going to be sometimes faster. Be sure that smaller LLMs that have substantially less parameters involved are always going to be faster, just because the input has smaller number of layers to trickle through to get there. And specifically talking about the number of activated parameters, because sometimes you have very, very large models that have smaller number of activated parameters. We're also going to say hi to our friend Brad here, saying frugality as well is a very, very good reason to choose a smaller LLM. Okay, excellent. You folks get it. So with that, we're going to choose Haiku because it's going to be a lower cost. It's going to be faster. And then we're presented with the ask to provide the instructions for the agent. So I'm going to paste what the PartyRock has generated for us, and it's going to include here the instructions for the algebraic operations agent, where it goes through a few steps that can easily be orchestrated to help the agent know how to navigate through this particular problem. So with that, if we just create an agent as is, this agent still cannot do anything different than what an LLM can do. It can just talk to us. But as we said with agents, we want to actually have some actions take place as well. So with that, we want to create some action groups that Forrest and Dash told us about. And we're going to create an action group here. We're going to give it some name. Again, I'm going to give it some maybe calculate action group as the name. And we're going to scroll further down where we get to define the action group with the API schemas. So that's the option we're going to select, because that is going to allow us to specify the open API schema here. And check this out. You can even have Bedrock create that Lambda function and configure it appropriately with the right permissions for us. So we don't have to create that from scratch. So that's the option we're going to choose here. But when it comes to the open API schema, we're going to define it inline here for simplicity purposes. So let's go back to the PartyRock app, and you folks can check out the PartyRock app as well and use it for a variety of use cases that come to mind as well. We're going to copy this open API schema, and we're going to plug that in here next. Replace this placeholder that's available. This is where whenever you're copying the values, you also want to just make sure that you're copying the right format of values. See, the reason that PartyRock app nicely formats the output here for us, because behind the scenes, there's a markdown language used that uses 3 ticks, and it specifies the format of how the content should be formatted. So if we take a look at what I copied over, you see these 3 ticks and YAML. We need to remove this because it's actually not a part of the Open API schema that we need. So I'm going to remove this because it's not necessary. In fact, it will break things if we keep it. And then at the bottom, we need to remove the remaining 3 ticks that tell us when this formatted content here ends. So with that, we have everything set up here from the Open API schema perspective, and this is going to tell our agent exactly how to call this tool here. And I'm going to go ahead and say create. So with this, now we have our tool created. A Lambda function is going to get created with the appropriate permissions. But hold on, this Lambda function still cannot perform the tasks that it needs to be able to perform. It's going to likely just have an empty Lambda handler function there. So we need to go in and we need to update that as well. I'm going to navigate to Lambda, and I'm going to say here, let's find the one that got created most recently. So I'm just sorting here on the last modified. There's one that got created 20 seconds ago. I'm willing to bet that's the one that we need. It's called calculate action group, and it has some unique suffix here as well. So this is the Lambda function that it needs to include the code that we want to be executed, to be running when the agent calls this tool here. And we're going to scroll here down further, and we're going to replace the standard default code that's available with what the PartyRock app has provided to us. So let's scroll further down to where the implementation for the Lambda function is. And I'm going to, again, copy this and plug this into our Lambda function. And again, I haven't done this in exact same way before, so let's see how this goes as we proceed to create it. So everything looks good. Again, you always want to validate and confirm that what you've copied over doesn't have any syntactical errors or any components that are going to potentially break things. And I think this looks good here. So we can go ahead and click deploy to deploy this Lambda function that can be used as a tool. With that, I think now we're in a pretty good shape to take this agent for a spin and see how well it does. So I'm going to say save here to save all these configurations that we've made. I'm just going to confirm that the instructions, okay, it looks like instructions have been wiped. So let's just go and copy that for our agent. So I'm going to copy instructions again, and I'm going to populate this as it didn't get saved as we were shifting through the different pages. And I'm going to say save again. Now, with that, we have all the necessary components, and you see immediately this prompt to prepare an agent has now been enabled. Now, what does this actually mean? Well, every time you make changes to the agent, you need to perform this preparation, which is going to lead to the Bedrock to load all the artifacts of that agent into its serverless environment and makes it available for us to utilize, to call, interact with that agent. But it looks like there's some errors as I try to prepare it. So it looks like an error here that's happening. It says math agent failed to prepare. There's an error during parsing of the Open API spec for action calculate action group. And for that reason, it has failed to create this object because it looks like here the Anthropic Claude 3.5 Sonnet model, and it looks like it did revert this to Sonnet, so we'll need to fix this, is going to be requiring this operand ID here. So that is something we didn't include here. But let's say that I'm not familiar with this error here, and I'm going to just copy this. And I'm going to go back into our PartyRock app, and I'm going to go into the chat, and I'm going to say, hey, this creation of the agent failed, and I'm going to say, I got this error message. And to make it very clear what the error message is, I'm going to enclose it here in the brackets, so it's very clear to this chatbot what the error is that I'm referring to. So I'm going to run this, and let's see what it comes back with. It's going to say, okay, Open API schema is missing the required operation ID field for the operation, which is required by the Anthropic models. And it goes ahead to fix this issue for us. And it gives me the updated schema, which if I scroll further down here, now includes operation ID. So effectively, I'm able to troubleshoot issues that I run into, and I'm going to copy this, go back into our agent here, and I'm going to make that adjustment. I'm also going to change, as I make the adjustment to the schema, I'm also going to change the LLM to Haiku, so we can go back to using a smaller model here. So with that, I'm going to now need to update. I'm going to save this. So the Haiku change gets saved, but also I'm going to go into the action group, and I'm going to paste that updated schema that we have now. So let's go into the calculate action group, and let's go into the schema here. Take a look at it in the viewer editor. I'm going to replace what we have with the new version of the schema. And again, if there are any edits here for formatting purposes, I'm going to remove that, but it doesn't look like there are any. It looks like this is just the content of the schema itself. So with that, what I can do next is I can go ahead and save this, and I'm going to say save and exit. And I want to now proceed with preparing preparing these changes for the agent. So with this, we should now be able to interact with the agent and present it with some sort of a prompt that requires calculations to be performed. So I can say, if I invest $13,000, I'm going to say $sign in one company, and that investment increases by, let's say, 4% in value, and I invest, let's say, $17,000 in another company, and that investment decreases by 2.5%. How much money do I have, as an example?
This sounds like a question from my accounting class when I took my MBA.
Yep, didn't have agents back then.
Okay. This is pretty magic, Ivan. Like, you literally just had Bedrock create a Bedrock agent for Bedrock. It's like this, Inception kind of thing, right? It's pretty impressive.
Yeah, absolutely. And in this case, we can see an example where that tool was not able to solve this problem. Now, that potentially could be due to the decimal points being included, but this is where, as Forrest told us, we can go to the traces and we can see what issue has occurred here. So if we expand here, we can see what the agent was thinking, what was the system prompt that was used. You can see it's far longer than what we've provided because of that default setting that Forrest talked about. And if we scroll further down, we'll be able to see the raw response that the agent has provided, as well as the rationale. So the rationale is, I'll solve this step by step. So it's applying that chain of thought approach, and it's going to say first investment 30,000 increased by 4%, second increase by 17%. I'll use the calculation function to determine the new values. And then it looks as it started working through calling that function the integration didn't quite work out in terms of how the operands are provided and how the numbers are being provided. So this is where you can go to the traces and you can optimize the implementation of that Lambda function. You can optimize the API schema that communicates to the LLM how the input should be formatted to ensure the Lambda function accepts it, and so on and so forth. Now, with this, we are running a little bit short on time, but what you can do on your own here, if you want to dive a little bit deeper, is go through this particular use case that we have here prepared for you. This particular use case is a use case for a marketing agent that goes far, far broader than what we've just done with one agent and one action item. It allows you to explore much, much more complex architecture that involves a variety of different services like DynamoDB, S3, OpenSearch Serverless exposed through knowledge bases on Bedrock. Amazon Personalize is a part of the solution. And I encourage you to go through this blog post and try and understand how this works. There's a solution implemented via Cloud Development Kit and CloudFormation that allows you to deploy this agent and run it in your account so you can familiarize with how this works. But now last thing that we want to make sure we cover before we start to close out, of course, is your home fun assignment. So this is where you can build your own Bedrock agent from scratch, and you can start small and simple. Try to go in the smallest increments possible, because you do not want to start off with something very complex that becomes very difficult to get to work, very difficult to troubleshoot. Use these helper tools that we discuss here to build the first version of your agent. So make sure you use that PartyRock app, you use the console and the agent builder that's available. And then if you want to add any additional feature, add those later. Make sure that that first version, the first proof of concept you build, is very simple so you can get it to work. And then you can expand from there with adding additional features that can be referenced by your agent there. So with that, I think we're going to start slowly wrapping up here. We've covered a ton in this session here. We have a home fun assignment for you here. So any last words, Dash, you have for our audience?
Home fun, please. As Ivan explains the home fun, make sure that you do the home fun. Tag us on LinkedIn. We'll put our LinkedIns in the chats. Tag us, hashtag home fun. That way we know that you're out there building. And if you want a season 2, we need to make sure that we get that social media interaction going, so we can come back next season with even more AI goodies. And I say that because James asked for season 2. So if you want season 2, just make sure that we're tagging that home fun. We're using that hashtag, and we're getting busy out there building.
That's right. How about you, Forrest? Any final word of wisdom for the folks?
Yeah, I like to just reiterate that sentiment and like join us again. We got one more episode of this show. Go find us on LinkedIn and do your home fun, and we'll share some more insight with you. Right? I mean, I feel like we could spend like 10 episodes just diving into every one of these topics.
At least 10.
At least 10, right? Although maybe we'll work on building like an agent that just like hosts these sessions in the future, maybe for us. I don't know. That wouldn't be as fun.
That's right. That's right. Thank you. Thank you, Forrest, for joining us. Thank you, Dash, for joining us. Has been an absolute pleasure chatting with you. Thank you to all of you for tuning in and keeping us company here, imposing some excellent questions. Make sure to tune in for the next episode, the final episode, episode number 4, and come prepared with some additional questions. If you have some questions in the meantime, reach out to us on LinkedIn. Let us know. Tag us, send us a message, reach out in whichever way seems easiest for you. Would be more than happy to address those questions as well. But with that, we're going to start wrapping up. Thank you all for joining us. Thank you to Forrest and Dash for joining me here again. And we'll see you in the next and final episode.